Okay, so this is a question on Magic Square that actually appeared in CAT 2017 slot 2. Now, this is the slot that I took the paper. I knew few things already about the Magic Square, so it became a bit easier for me. But I would explain the idea from the perspective of the question in a very simple manner. I mean, whatever is required, you don't have to solve the entire grid to figure out this particular answer. Also, that in our prep module, we have explained how to approach this kind of thing in a detailed way. But then the question is very important. So depending on the question, you should focus. But there are some basic ideas that has to be understood any which way. So we will be discussing that first. So for example, in this particular question, so you have a 3x3 square grid in such a way that each number occurs one. So each number is this 1 to 9, and the entries along each column, each row, and each of the two diagonals add up to the same value. That is essentially the definition of a magic square. Now, if top left and top right corner entries are 6 and 2 respectively, then the bottom middle entry is how much? So that is the question. Now, coming to the approach here, first of all, whenever you have this question, so uh, ideally you should draw a square. So let me do that quickly. So you have this 3x3 grid. Now, what you know is each row, each column, and etc. So each row should be adding up to the same number. Each column should add up to the same number, and each diagonal. So by diagonal, it means the main diagonal here and the main diagonal here. So each of these diagonals should also add up to the same value. Now, if you compare a row and a column, there will always be some overlaps, right? So if you consider this row and this column, so this entry or this cell, whatever entry that is in the cell, that would be double counted. But if you think about I mean, this will happen with diagonal and column as well. I mean, diagonal row as well. So whichever row you pick up and whichever diagonal you pick up, there will be some overlaps. But then if you consider each row or each column, so whichever perspective you want to take, now, each row will have absolutely different entries, right? So there is no overlap between the rows. Any entry that is in the first row is not going to be in the second row, and again, anything which is in the second row will not be in the third row, and also for the first row and third row. So we can definitely consider that all the numbers are appearing exactly once in each of these. I mean, in this entire grid, and there are 9 numbers that we are allocating in this 9 cells. So effectively, what we can claim is whatever is the total of 1 to 9, that is 45. I hope everybody is aware of 9 into 10 by 2 and into n plus 1 by 2. So whatever is the total here, this total should be the sum of the 3 rows, isn't it? Because we have distinct entries in each of the rows. So effectively, what we can say is each of the rows should be adding up to 15. And if each of the rows add up to 15, according to the given condition, each column should add up to 15, each diagonal should add up to 15. So this is the idea here. So the sum that it talks about, so each of the adds up to the same value. The same value is essentially 15. Now, what else do we know about it? So first of all, we know that the row or the top left and top right entry has been given. So you can ideally start with that itself. But before getting into that, or rather, let's try to understand why I'm asking you not to start directly. You can start, but then you have to understand something more to continue. So once you put in these entries, so 6 and 2, the top left and top right entries, you will automatically get this one, right? Because the total should be 15. So 6 and 2 is 8, and then obviously the middle one has to be 7 to fulfill the 15, right? But then if you try to fill the other 6 values, it will take some doing. I mean, you have to figure out a lot of cases and everything. So not to do that directly, let's try to understand some few things about this square here, and that is about the numbers. So for example, if you consider this 7, there's a reason that why this 7 is coming in this particular cell. So if you put it in this way, this cell is like an edge of this magic square, isn't it? So if you consider this particular edge, the one that I've highlighted just now, it will be part of this column which adds up to 15, as well as this row which adds up to 15, right? And this column should be adding up to, because this column adds up to 15 and this row adds up to 15, there should be uh, there should be two different ways to get a sum of 15 using the 7. And that is precisely the reason the 7 goes here. I mean, think about it. The 6 and 2 that we use up in this row with the 7, we cannot use up 6 and 2 again, right? Each of the cell has to have different values. So essentially what we know is, I mean, there has to be another combination which gives us 15, isn't it? So let us focus on that. Now, if you look at this 7, what else do we need, or how much more do we need to get a 15? So we need a total of 8 more, right? Now, one of those ways to get the 8 is obviously 2 and 6, which is written in front of you, right? 6 and 2, which was given in the question anyhow. What is the other way? So if you think about it, I mean, this is 8. We cannot get 1 and 7 again, because you cannot use a 7 with a 7. So you cannot fill two sevens, something like this. I mean, you cannot fill another 7 on this particular column, right? So you cannot make 8 using 1 and 7. 2 and 6 is already gone. 3 and 5 is one possibility. And again, you cannot use 4 and 4, right? You cannot use the same number twice. So 3 and 5 is the only possibility that you can have. And focus on the question. What is the question asking for? Then the middle, then the bottom middle entry. So the bottom middle entry is basically this particular square, right? So the one that I'm highlighting right now, this is the square in question. So now, if you think about it, there are only two possibilities that you can get using 3 and 5. That you can have for this middle entry, and that is 3 or 5. So again, focusing in the same way, if you do take into consideration this particular cell, this cell is also part of one row and one column, right? So if it is part of one row and one column, we should find 15 or make 15 with the number that comes here in two different ways, right? Because it should be making a 15 in a row, and it should be making a 15 in a column. So let's look at these two numbers that we have attained, and that is 3 and 5, which will definitely come in this particular column, which has 7. So let us look at the number of ways we can make 15 using 3 first. So if we try to make 15 using 3, the number of ways we can do that, we need 12 more, right? In order to make 15. So we could definitely make it with something like 4 and 8. We cannot make it with 3 and 9. We cannot use another 3. So 4 and 8 is feasible. And another way I hope you can see is 7 and 5, right? So obviously this particular combination is also one way, right? So 7 and 5 is one other way. 6 and 6 again is not possible, right? Because you cannot use 6 couple of times. So I hope you can see that 3 can be used to make 15 in two different ways. So definitely 3 can come in this square. I mean, can definitely enter this square. But what about the middle square? I mean, in this column, you also have this middle position, right? So one of these numbers out of 7, 3, and 5. So 7 is already on the topmost part, but one of these 3 and 5 will also occupy the middle position, isn't it? So if you think about this middle square, how many ways it should make 15? It is part of one row, it is part of one column, and it is part of both the diagonals, right? So essentially, 15, or rather, this number should make 15 in 4 different ways, right? And that is definitely not 3. We have figured it out, because 3 is something which is making 15 in 2 different ways, right? These are the only 2 ways it can make 15. Now, the only number that could be in that case, because we have this clue already that 735 has to be in this column, the only number that could make 15 in 4 different ways should be 5, right? If you want to test it out, you can test it out. You can check that with 5 you need 10 more to get 15. So you could have 1 plus 9 You could have 2 plus 8. You could have 3 plus 7. So this 375 is the combination of this column. And also you could have 4 plus 6, right? So these are four different ways that you could make 15 using 5, right? You cannot use 5 and 5, so all fives are not allowed. You cannot use 5 multiple times. So effectively what we know is 5 should come in the middle and 3 should be at this position. So the answer to this is 3. If for just for the interest you want to solve this entire thing out, you should not try to do that in the exam. But just because of interest, if you want to solve it now, it is very easy, because if you focus on this diagonal, this should add up to 15. You already have a 2 and 5, so that makes 7. You need 8 to make 15. This diagonal should also make 15. You have 6 and 5, that is 11, so you need 4 more. And now you naturally see that 8, 3, 4 is also making a 15. And again, in this column and this column, you can simply fill it up. 6 and 8 is 14, so this is 1, and only 9 is left out. So that is the entire according to this particular uh, setup. So you already place the top left and top right, so that is sufficient to fulfill the the magic square completely. Otherwise, there are a lot of different arrangements of this magic square because of symmetric nature. So I hope that was understood. I just wanted to detail a bit more on the logical part so that you can solve it if you don't know how to solve it. If you know how to solve it, then you should be knowing that 5 should appear in the middle. And as soon as you know that 5 appears in the middle, it's something like this. Let me show you what I did in the exam. I knew that 5 has the most number of possibilities to make 15. So 5 should be the one which appears in the middle. So 6 and 2 is already here. So that should give us 5, 7 here. And because 5 is in the middle, there should be a 3 here. That's it, done. So it's a very fast question if you know that idea. And even if you don't know it, you should be able to solve it in the exam. So ideally, even if you don't know it, you should be able to manage to solve it within a minute or a minute and a half, I mean to say. So somewhere in the range of 1 to 1.5 minutes should be ideal to solve it. You can actually solve it in less time. So that's it for this question. I hope you enjoyed this. This is an interesting question that appeared in CAT. So thank you.